Good evening, students. So today we are going to study a topic called fractions. Okay, now this is a relatively basic topic in mathematics, but there is a reason why I am taking this up, because there are some parts of this particular topic which are not that popular with students, and therefore they are usually not in a state of mind where they remember some particular kind of fractions. Okay, although even at 9th and 10th level you do come across that particular part of the topic, but it is, since it is not usually popular and it does not appear so often in the normal course of study, therefore it is more or less kind of forgotten while the studies go on. So we will understand that part in detail. Okay, see, fractions as such, we all know that we have a number of types that are there. So we have what we study as proper fraction. So if we just want to break this down, we have proper fractions, okay, and then we have improper fractions. We have improper fractions. So let's take the help of these two topics to understand what fractions are. Now see, fractions are numbers. Okay, so just like we have natural numbers 1 2 3 4 5, similarly we have whole numbers starting from 0 and so on. Similarly we do have fractions. Now these fractions are basically the reason why they are classified as a separate category of numbers is because they usually tend to indicate some parts of unity, okay, or let's say equal parts of something. Okay, so for example, the very basic example that people usually give is the example of a cake. Okay, so usually suppose this is a cake, okay, and we now this whole cake will be treated as one, okay, because it is full. The entire cake is here, so that will be treated as one or a whole. Okay, so the entire thing is here. And if I want to simply break it down into two, or I want to distribute this whole cake into two equal parts, so essentially what I am doing is, when I do this, how do I represent each part? Let's say, for example, earlier I was representing the whole cake. So let me just draw another diagram to help you understand. Suppose I have this. Now this is to be treated as a full cake. Therefore, if you want this whole cake to be picked up, so I will say that I have picked one part out of the one part. Okay, because I have essentially picked up the whole cake, and the whole cake as such in itself was being treated as one. Okay, the whole thing. Therefore, since I'm picking up the entire thing from the entire thing, so I'm not leaving anything behind. So essentially, if you want to write this expression, this picking up of the whole cake in terms of fraction, then I will be writing it as 1 by 1. Okay, because this part that I am picking up is in the numerator, so let me write that as numerator here, and this part naturally is known as the denominator. Okay, so what are these numerators and denominators going to represent here? The denominator represents the whole thing, and the numerator represents the part of the thing that has been picked up. Okay, so since here both are the same, therefore 1 upon 1. But it is not so in this particular case. Suppose I have the full cake over here, so that full cake will be treated as 1. Okay, so that forms the denominator. But if I want to pick up only the half part of it, so essentially what I am doing is, I have broken the whole cake into, let's say for example, I have broken the whole cake into two parts. Okay, so how many total parts were there? 2. Okay, so the 2 will come in the denominator, and how much have I picked up? How many parts of these two parts have I picked up? I have picked up only one part. Okay, so this becomes half, or this becomes 1 by 2. So what is this indicating, 1 by 2? This is a fraction which is indicating, this is a number which is indicating that how many parts of that particular whole thing have we picked up. Okay, so we have picked up one out of the two parts. Okay, so this is how we understand fractions. Now coming to what I wanted to discuss here in terms of the proper fractions and the improper fractions. So you see, children, if you recall, in the earlier classes, you might have probably in third, fourth standard, or maybe in fifth standard, you must have studied fractions. So when you talk of the numerator and the denominator, you can have several examples, like you can have 2 by 5. Similarly, you can have 1 by 2. So you can have 8 by 9 also. And you can have, let's say, 5 by 4 also. Okay, so these are several examples, and certainly you can have minus signs also along with that. So these are all fractions. Why are they fractions? Because they are numbers which have been expressed in a particular format where there is a number at the top, then there is a line, and then followed by another number below that. Okay, so there are two numbers separated by a horizontal line, or you can also write it as this 5/4. Okay, so this usually is 5 by 4. Okay, so now you see, these are all fractions. We have understood what fractions are, but there is a proper classification of fractions. So if you see here, in this, and this, the first three cases, if you notice, children, the first three cases, you will find that the numerator is lesser than the denominator in all these cases. You see, 8 is less than 9, 1 is less than 2, 2 is less than 5. So any fraction in which the numerator is lesser or the smaller than the denominator, such fractions are known as proper fractions. Okay, whereas improper fractions are those fractions in which you can see the numerator is greater than the denominator. So that comes under the category of improper fractions, which can be further simplified into what? So let us see, this improper fractions can be further simplified into what is known as mixed fractions. Okay, so they can be written as mixed fractions. Now, what is the reason why we are using the word mixed here? Because if you see 5 by 4, now this is essentially the significance, the meaning of 5 by 4 is that 5 is getting divided by 4. So when you divide 5 by 4, what do you get? You get 4 ones are 4, then 1 remainder, and 4 in the denominator. Okay, so essentially what you are having is 1 whole 1 by 4, because 4 into 1 is 4 plus 1 5 upon 4. So essentially what we are doing is we are expressing the improper fraction in terms of another kind of a fraction or another way of writing the number, in which a whole number is written separately followed by a proper fraction. So you see, this one is a whole number. Okay, whereas 1 by 4, you can naturally see that this is a proper fraction. Okay, so with the help of this, we have come to know another type of a fraction which gets its life basically from this improper fraction. Okay, so what are improper fractions? These are all fractions in which numerator is greater than the denominator. Therefore, you can actually divide. So 4 ones are 4 and 1 remainder upon 4. So you have one whole number coming out and one fraction coming out. Okay, so these are mixed fractions. Now, this was not the reason why the topic has been picked up. So the topic has been picked up because of another reason. So let us all see. We have something which is called as decimal fractions. Decimal fractions. So now what are these? Naturally, you all understand the word decimal. So decimal numbers, they are not any different from fractions. They are a part of fractions. Okay, the only different thing about them is that they have a separate way of how they are written. So a person can write 0.5 as a number in front of you. So what is this essentially? This is a decimal fraction. Why? See, decimal, because we put a decimal here. The reason why it is being called as a fraction is because essentially, you see, this can be again expressed as, you all know as mathematics students, that if this is to go, this decimal is going to go to one place right of this number, then you have to divide by 10. So essentially this becomes 5 by 10, which can be further cancelled. 5 ones are 1, 5 ones are 5, and 5 twos are 10. So it can be expressed as this also, it can be expressed as this also, it can be expressed as, so essentially all these three things are the same things. Okay, so wherever it is written with a decimal sign, they are known as decimal fractions. But if they are written like this in the sense, one number upon another number, so that one number is in the numerator, another is in the denominator, separated by a line in between, so then they become either proper fractions or improper fractions. Okay, so these are all fractions. Okay, now comes the part which is called as vulgar fractions. Okay, so this is something that is the one which confuses people more. Okay, so we will discuss this part of the lecture also. So we have vulgar fractions. Now what are these vulgar fractions? So when we talk of vulgar fractions, you see, they have a very wide category. Okay, they have a wide classification. So when we were discussing fractions, we discussed that they are also numbers. Okay, they are numbers which are written in a particular way. So let's say, for example, this is a number. 1 upon 3 is a number. The only difference between this number and a number, let's say 5, is that it has a definite way of writing, and it expresses one part out of 3. Okay, so this is the difference. Now you see, these fractions, and like let's say 1 upon 3 and 5 upon 3. Now I told you that this is a proper fraction and this is an improper fraction. Now both can be called as vulgar fractions, because the reason why we use the term vulgar fraction is because they are basically different from decimal fractions in the sense that they do not have a decimal. They will always have one number in numerator upon another number in denominator. Okay, so when we say that 1 upon 3 is a fraction, 5 upon 3 is a fraction, so what is a fraction? A fraction is a number or a particular way of denoting a number in which you actually write two numbers separated by a line in between. Okay, so all these ways of writing fractions, they are known as vulgar fractions. Okay, but if somebody writes it like this, let's say somebody writes 1 by 3 as 0.33, because if you divide 1 by 3, you are going to get 0.33. So is this number any different from this number? Not in the value. Okay, the values of 1 by 3 and 0.33, they are same. Okay, they are not different in terms of value, but the reason why they are different is, look at the way of writing them. Okay, the same thing is being written in two different ways. Okay, so this way of writing is what you call decimal fractions. Okay, whereas if you express it like this, one number upon another number, one number upon another number, then they are known as vulgar fractions. Just keep in mind that vulgar fractions, usually the denominators are not 10, 100, 1000 and so on. So the only exclusive identification of a vulgar fraction would be that their denominators are usually not 10, 100, 1000 or multiples of 10. Okay, they can be any other number apart from that. So if somebody gives you asks you a question, let's say that this was a proper fraction, okay, because the numerator was lesser than the denominator. This was an improper fraction because the numerator was more than the denominator. So both are fractions and they have different names. But can both of them have a generic name also? So the answer would be yes, and that answer would be vulgar fractions. Okay, so both these are vulgar fractions. They can in general be categorized as vulgar fractions. Okay, so both of these are vulgar fractions. But if you want to separate these two vulgar fractions more specifically, then you will say that this is a proper fraction and this is an improper fraction, which can be further expressed in mixed fraction, okay, which I just now showed you. Okay, so these are vulgar fractions. Now we'll do some conversions of some decimal numbers into vulgar fractions to help you understand the term better. Okay, so let us see. We have let's say, for example, we have a question: express 8 whole 5 by 9 in vulgar fraction. Express 8 whole 5 by 9 in vulgar fraction. So if this number is to be expressed in vulgar fraction, that naturally means that it is not already vulgar. Okay, so you have 8 whole 5 by 9. So this is a mixed fraction, if you remember. So 9 8s are 72. 72 plus 5 will make it 77 upon 9. As simple as that. So this is what you know as a vulgar fraction. Because remember, children, when I told you vulgar fraction just now, I told you that they involve both proper as well as improper fractions. So any number which is expressed as one number upon another number, all such numbers will be vulgar fractions, except for the numbers where the denominator is 10 and multiples of 10. Okay, so 77 by 9, although you can see that the numerator is greater than the denominator, but it is still a vulgar fraction. Okay, if you want to give it a more particular name, you will say that it is an improper fraction. Okay, but since the question was to express this in vulgar fraction, so this is how the vulgar fraction comes. Okay, now let's take up another question. Okay, so the next question is to express 1.3 with a bar at the top on 3 as a vulgar fraction. Okay, so naturally it means that this number that we have is not already a vulgar fraction. You can see that it's a decimal fraction. Okay, and one more unique thing about this decimal number here is that you can see a small bar at this above this number 3. So essentially this means that this number is 1.333 and so on. So the bar on a number essentially means that that number is getting repeated. Okay, or this is a circulating decimal. You can also use the term repeating decimal, circulating decimal, recurring decimal. Okay, so there are different names. Let me just tell you all these names. Recurring, because the digit 3 is occurring multiple times, or you can also say that this is repeating because the digit 3 is repeating. Then they can also use the term circulating decimal. Okay, so these are all different names that you have for this particular such particular kind of decimal numbers. Now coming to our question is that I have to express this 1.3 bar as a vulgar fraction. Now please note, children, that this has a particular way of solution in terms of steps. So the first thing that you will do is you will assume let our number x be 1.3 bar. Okay, so I have allotted this value to constant x, so you have used an alphabet for it. The reason why we do so is this essentially means that I am going to write this as this, because just now I told you that 3 with a bar means 3 is getting repeated. Okay, in the next step what you do is you can see that since x is 1.3333, so what will 10 times x be? 10 times x means that 10 is multiplying x. So when 10 multiplies x, this decimal shifts here. So simply it becomes 13.3333 3 and so on. There is no shortage of 3's. There are multiple 3's that are there. Okay, so please look at this step very carefully, because you see, you can do 100 times x also. Okay, you can do 1000 times of x also, but you must understand, the reason why we are discussing this here is that you should understand when and where 10 times x will be applicable, and where do we have to use 100 times x. So you see, after doing this, let me write this particular step here just below. So I am going to write this, and then I will subtract. Okay, so essentially what I am doing is I am subtracting. If I, let's say, call this as equation 1 and I call this as equation 2, so essentially what I am doing is I am doing 2 minus 1, and you will come to know why am I doing it. You see, when you do 10x minus x, you get 9x, okay, on the left hand side. Similarly, on the right hand side, if you notice, children, this is the reason why we subtract, because after subtracting the right hand side numbers, you can see that the decimal portion of both these numbers is exactly the same. Okay, therefore when you subtract, the decimal portion will go away and you will be left with 13 minus 1, which will give you a 12. Okay, which will essentially give you x as 12 upon 9, which will give you 3 4s are 12 and 3 3s are 9. Okay, so you understand this form 4 by 3. What is this that I have got? This is nothing but my x. Okay, this 4 by 3 is a number which is expressed in a particular format. If you remember, children, this format is one number upon another number, and this is exactly what is a vulgar fraction. Okay, so what was our question? Our question was to express this 1.3 bar as a vulgar fraction, because this was a decimal fraction. Okay, so what did we do? We multiplied this. First we assumed that this number is x, then we multiplied 10 with x. Why 10 now? Please understand that this decimal has only one digit before itself. Okay, had it been 11.33, then you would have done 100 times x. Okay, so this is what you would probably do, and I'll show you this with another example also. So first what you do, you multiply it with 10 so that it becomes 13.3333, and then after that you subtract. The reason why you subtract is because you want to get rid of the decimal portion. So this is how you convert. Okay, now let's go to the question where we have to multiply by 100. Okay, so let's have a look at this particular question. You have to express 0.43 bar as a vulgar fraction. So the question appears to be similar, but if you notice carefully, the bar this time is on 2 digits. Okay, so let us say that x is 0.43 bar like usual. Okay, so that means that my x is 0.434343 and so on. So if you notice, children, this time it's not a single digit after decimal which is repeating. In fact, it is the combination of both these digits which keep repeating. So 43 43 43 and so on, because the bar is on 43. It is precisely these questions in which you will have to multiply this x with 100 and not with only 10. Okay, because you see, if you, I'll show you why 10 times x cannot be done here is because if you do 10 times x, what you will get is this decimal will move only one place. So that will give you 4.343434 and so on. So now when you will subtract this equation from this equation, you can see that the decimal portion is not the same, because here it is starting from 4, here it is starting from 3. Okay, that is the reason I'll show you that when you multiply this x by 100, this time you have to move the decimal to 2 places here. Okay, so that when you multiply, this actually becomes 43.434343 and so on. 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 Okay, so now you see it is after multiplication by 100 that this decimal has moved 1 2 place here, so that you have the same number, decimal numbers repeating. Okay, so now when naturally when you subtract this, so let's say for example this is equation number 2, this is equation number 1. So when we do 2 minus 1, so what do you get? 100x minus x will give you 99x on the left hand side, equal to 43.434343 minus 0.4343. So you see the decimal portions are same, therefore 43 minus 0 you get 43, and therefore you get the value of x as 43 upon 99. If you want, you can see, you can just check if that can be simplified. I think this will be your answer. This will be your vulgar fraction. Okay, so this is how you convert the decimal, repeating decimal numbers or the circulating decimal numbers into vulgar fractions. Okay, so this is a proper way in which you do it, and that is why I took up this particular topic. So hope you have understood this. Please remember that only the portion above which there is a bar will be repeated. Okay, so that is it.